We are going to pick section 1.1 up with interpreting function notation in context. So we're going to do a lot of interpretation or contextual interpretation in this class. When you start getting into the higher level maths and when you're applying math to real life situations, it's important that we're able to translate words to mathematical notation and mathematical notation to words. So in this case, we have a function p of x, and it tells us that gives us, that's a signal or a word that means equals. So we could say that p of x gives us or is equal to profit, and profit is in thousands of dollars. And now it's going to tell us a little bit more. It's going to tell us that x is the number of units sold and profit is in thousands of dollars. So another way that I could write that, I could say P of my input. What's my input? P of x. What's my x value? Number of units sold is equal to profit, P, profit in thousands of dollars. Thousands of dollars. Okay. So we want to write a complete sentence, and I will be asking you to write complete sentences, and we would want to interpret, in this case, this expression, which is in function notation. This is function notation right here. P of my input, 370, is equal to 19.5. So let's talk about what is the input symbol. Well, the input symbol, the input is always inside the parentheses. Okay, and in this case, x is inside the parentheses, and it tells me here that x is the number of units sold. So my input variable or symbol is P, and if I write that in context, that is P is the number of units sold. And then if I look for my output, okay, my output is P, right? P. I input the number of units sold here, and I get an output of P, profit. So my output symbol is P, and that is profit in thousands of dollars. So if I write that, well, I kind of have it written here already, like here, okay? So if I want to write my sentence, I can summarize it here. P of number of units sold is equal to profit in thousands of dollars. All right, and so what I want to interpret is this expression here. So I have P of 370 is equal to 19.5. So let's translate this. So I'm going to type this here. So it says, when I sell 370 units, I have a profit of, I see here that it's 19.5, but that represents thousands of dollars. So that is $19,500. And I would like you to write it out. I don't want you to write, well, technically it's correct. I don't want you to write like 19.5K. We're talking about money here. I really want you to write it out fully. So this says, when I sell 370 units, that's my input, then my profit or my output is equal to 19.5. That's thousands of dollars. So I'd have to multiply that by 1,000 to get $19,500, which is what I would write here. Okay, and so if I talk independent and dependent variables, the profit or my output depends on how many units I sell. All right, let's move forward. So now if I want to use kind of the words and then write that in function notation and vice versa, okay, we can do that as well. So here I'm told that the amount of garbage in tons produced, the amount of garbage is G, and that is tons produced by a city that has a population of P, and P is measured in thousands of people. So really make sure you're focusing on the units of these problems. They can be a little tricky sometimes. And then we are told that this scenario is given by the function G, tons per week, is equal to F of P. Okay, so if I input, P is inside the parentheses. When I input how many thousand of people I have, I can tell what my tons of garbage per week are. All right, so let us summarize here. What is the input variable? Well, the input variable is the thing inside the parentheses. So the input variable is P in this case, P. And if we want to talk in context, that just means for this specific problem that's being described, we want to put it in words or contextually. So the input variable in context is P is thousands of people. If I want to be more specific, I can say in whatever the city is. Didn't tell us what city, in the city. And my output variable is G. So G is the output variable, and what does G represent? Contextually, G is tons of garbage per week. So G is tons of garbage per week. All right, so now let's focus in on, it's asking us if the town of Fishkill has a population of 35,000 and produces 7 tons of garbage each week. If we want to write this in function notation, here's my function notation, G equals F of P. How would I translate this? Well, I know that I have to write P in thousands of people, so I have 35,000. So I would actually write that as P equals 35, okay? Because when I write this by definition in function notation, I'm only representing how many thousands of people. So I would say F of 35 is equal to, and then G is 7 tons of garbage each week, equals G. And I know in this case that G is 7 tons. Okay, so now I've translated the words to function notation. When I input, or when I have 35,000 people in Fishkill, town of Fishkill, I will generate 7 tons of garbage per week. All right, let's move on to business functions. So business functions, we're going to work with a lot with in this class. And so the first important one is revenue. Revenue is just how much money did I earn from sales? So if you think about it, if you're working in a convenient market and you want to figure out how much revenue, let's say you only sell ice cream at that convenient market, and you want to find how much revenue did you earn? Well, you would take how many ice cream cones did you sell times how much did you charge. So revenue is the price charged per item times how many did you sell. So we write it here. We can write it a bunch of ways, I guess, because depending upon what our variables are, but here my input variable is X. So whatever variable is inside the parentheses, it's always going to show up here as well. So this is my price, P, times my quantity of items, or X. Another way that you'll come across this is revenue equals P times Q. You'll hear that in business a lot. I like to write it the other way, P times Q equals R, if that helps you, because they're sort of alphabetized. PQR they all come right after each other in the alphabet. That can be an easy way as you're getting to know these to remember how they're defined. All right, so now we want to look at cost, total costs, and total costs have two components. We can have fixed cost, or let's say initial cost. Let's say that you are going to sell cupcakes at a local farmer's market, and you have to pay a fixed cost or initial cost of, let's say, $100 to set up your tent. So that doesn't depend on how many items you sell at all, right? You have to pay that even if you sold no items. And then you have how much did it cost you for each cupcake that you had to make. So you had flour and you had sugar and you had other things. And so there's a cost associated with each cupcake. So that's your variable cost. Variable cost times quantity of items. Okay. And so then I want to figure out my profit. Well, my profit is just equal to my revenue minus my total costs. And if I write that in function notation, P of X is equal to revenue minus cost. So think about it. Even if you sold 100, or let's say you sold $200 worth of cupcakes at the farmer's market, but that's not how much you had to left over to put in the bank. You had to pay to make the cupcakes, and you had to pay to have your tent there. So you have to subtract those costs off to find out how much are you left with to put in the bank. And lastly, we have break even. And break even just means where profit equals zero. Break even point is where profit equals zero. So if profit equals zero, I just told you that revenue is equal to profit equals revenue minus cost. And if that equals zero, that's just like saying that revenue is equal to cost. That's another way to describe break even. You don't make any money. So if I look over here, and this is my cost function, and this is my revenue function, that point where they're equal, that is where my profit is zero. And you can see prior to that point, I am in the red, okay? My costs are greater than my revenue. Once I get to the break-even point, cost is equal to revenue right here. And then once I get beyond that break-even point, now my revenue is greater than my costs, and I'm in the black. Okay? So we're going to do more with this in some word problems. That's the summary. Let's look at an example. So if I have a manufacturing company and I make some widgets, and I want you to look for keywords when you're going through these problems. So this says I have fixed costs, okay, of $500 per month. And then I have a cost per widget of $9. Then I'm told I sell them for $26 each. All right, X is the number of widgets. So my input, so here's my cost. I want to write the cost function, C of X. Well, my input is the thing inside the parentheses. So my input is X in this case, and that is right here. It told me the number of widgets. And so my output is going to be cost. So that I could write as C. That's my cost. So now we need to write that function for cost. And if you recall back here, cost has two pieces, fixed costs and variable costs. So that's what we're trying to find, the two pieces. Well, it just told me straight out here that my fixed costs are $500 per month. So let's start writing this. I've got my cost is equal to 500. Okay, that's my fixed cost. Plus, how much does it cost me to make each widget? Right here, the cost per widget is $9. So I have $9 times however many widgets I make. So notice that you're always going to have that variable on the right-hand side of the equal sign. That is going to then help calculate or determines how we calculate the cost function. All right, good. So now I want to write the revenue function. The revenue function. Revenue is equal to, I like to say, P times Q, which tells me price times quantity. That's what P times Q is. Price times the quantity sold. Well, in this case, X is the quantity sold. So this is, and what is my price? So I know this is going to be X. What did I price them at? I priced them, or I'm selling them at $26 per item. So I have R of X is equal to 26 times however many I sold, but I don't know how many I sold. So I'm going to put that X there. That's sort of my placeholder for the quantity sold. X represents the number of widgets that I sell. All right. So then we want to write, or when it says give the profit function, it wants you to write the function for profit. So we know that profit is equal to revenue. How much money did you take cash in hand minus how much did it cost you to make those things? So here's my revenue function. I've got 26x. I'm just going to plug in, right? Minus, now I really encourage you to use brackets here. A lot of times people a common mistake is they don't subtract the entire cost function. My cost function is 500 plus 9x. Okay, so I need to subtract both those pieces. So I'm just going to say here's my cost function. I just picked that up here, right? Cost. And then here's my revenue function, R of X equals 26x, all right? And so now if I want to write this profit function in simplified form, I've got to distribute that negative. So this becomes P of X is equal to 26x minus 500 minus 9x. I can further simplify that. I can combine 26x with negative 9x. So this is equal to 17x minus 500. This is what I would be expecting if I asked you to simplify that. That's my profit function. And then the next part says, what is the minimum number of widgets that we must produce to make a profit? So remember from the prior page, right? I usually start off where my costs are greater than my profit. I'm in the red. Then when revenue is equal to cost, this is my break-even point. That's where profit equals 0. And then once I get past that, okay, when my units sold are great enough that I go past that break-even point, then I'm making a profit because profit now is greater than my costs. So in order to find out how many things I need to sell to make a profit, I usually want to find what that break-even point is. That's where profit 0. And then if I need to sell an additional item to make a profit, that's what I would have to indicate here. Okay, so I know that when my profit equals 0, that's my break even. So I'm going to try to find that break-even point. I'm going to solve for how many units should I sell so that my profit is 0. So we know here's my profit function here. I'm going to say P of X equals 0, and then I know that profit is 17X minus 500. And so I'm going to solve for how many items? X. Okay. So I need to just do some algebra. So my goal is to get X equals something. That's my goal. So I've got 17X minus 500. I got to add 500 to both sides. And I get 500 is equal to 17X. All right. This is my goal. I'm not there yet. So I have 17 times X. I want to undo the multiplication. So I'm going to use my inverse operation. I'm going to divide both sides by 17. And I get X equals 500 over 17. And if I put that in my calculator, that's 29.14. Okay, so I've got it graphed down here. So my break-even point is right here at when I sell 29.14 units, I get a profit of 0. Well, I can't sell partial widgets, okay? So in order to make a profit, I'm going to need to sell one more. So I would need to sell 30 items to be up here in the black, okay? If I sold 28 items, I would be on this side. I'd still be in the red. So I'm going to sell 30 units. Okay. So now if we have functions and tables and we want to interpret them, we can do that as well. This is similar to the earlier problems we did. I have a table here. It relates number of rats to the rat population. Again, I'm going to have my inputs on the top row and my output on the bottom row. And it says evaluate and interpret P of 2. Well, my input is inside the parentheses, so that means that I'm going to go, here's my inputs. I'm going to travel over till I find 2, and then I'm going to read the table that is equal to 1080. So if I want to interpret that, I would say, because my inputs represent weeks, I'm going to say after 2 weeks, the rat population is 1080. That's how I would interpret that first part. And now in the second part, right, I'm given the output. This is the output. I want to solve for the input, which is W. All right, so this is my output. I'm going to go to my output row and I'm going to travel over until I see 1160. When I have an output of 1160, it means that my input, or W, is 4. So I can rewrite this. I can solve using the table. So I have P of 4 is equal to 1160. And if I translate that, now I would say after 4 weeks, the rat population is 1160. And then I can do the same thing with a graph. So if I were to evaluate, interpret this, F of 1000, I can see again on a graph, my inputs are on the horizontal and my outputs are on the vertical. Whatever is inside the parentheses is my input. It's asking me to evaluate. It means it wants me to find the value of the output. So I want to know what this value is. So I'm going to look on my inputs. Here's my inputs. I'm going to come over. I find 1000. I'm going to travel up until I hit the graph right there. And when my input's 1000, my output is 14. So I can write this as F of 1000 is equal to 14. And if I translate this, that would say, I'm going to look to see what does my input represent. Well, my input represents depth and my output represents temperature in Fahrenheit. And so I would just translate this sentence to say, when I am at a depth of 1,000 feet, it's important to use the correct units here. The water temperature is 14 degrees Fahrenheit. Okay, and we can do the same thing for solving. In this case, we are given the output and we want to solve for the input. So my output is on the horizontal axis, so I want to find when does the output equal 28. So I'm going to come up here, I'm going to come on my output. Here's 28 here. I'm going to travel till I hit my graph, and then I'm going to read what the x value is, and I can see it here, right? 528. So I know that f of 500 is equal to 28, and then you could translate that just the same. This is my input, this is my output.